Okay guys, it's me Imad from Nelson Darwin ParkTech YouTube channel. So in this video tutorial we will learn how we can make a power failure detector circuit within the Proteus by using PIC18F452 microcontroller. So for it, first of all we need to take our AC source and we will take alternator as our AC source. So it represents the power coming, AC power coming from our mains. Okay, now we will do one more thing. We will take one push button. Okay, so this is our SPST push button, single pole, single throw push button. Okay, now we will connect it like that. Okay, after we need to take one transformer. This is our transformer. We will take our simple transformer. You can put it like that. Okay, now we will connect it with the push button. The other end of the coil is with the alternator. Okay, now this is our setup for the input. Now on the output side we need to do one more thing, and that is the setting of the parameters of the transformer. So you need to put 40 Henry here or 45 Henry here, and here you need to put 0.1 Henry. Okay, now we will measure the output voltage. Take AC voltmeter and connect it like that. Okay, wait. You also need to change it to 220 volt and 50 hertz. Okay, 220 volt, 50 hertz, and here we need to write 45 Henry and 0.1 Henry, so we can change it to 0.5. Okay, now what will happen? We will see. Can we alter the frequency? Yes, we can. 60 hertz, and still no response. Oh yeah, because we have not pressed the push button. Okay, so it's 15. So we just need to write 0.1 Henry, and now our voltages on the output side are just 7.33. Okay, now we will just delete this. After it we need to take one bridge rectifier. Generic bridge rectifier. Okay, now we will attach it with this and like this. Also we need to connect the output side of the bridge with the some protective circuitry. But first we also need to check the DC with DC volts on the output side. Okay, now we will check, and here we are just getting 1.28 volts, although there is drop inside the diodes like 0.7 and 0.7, so it is 1 point something. Okay, we also need to do one more thing, that we also supposed to attach the ground. Okay, ground on both sides. Even we can attach the ground on this side. Okay, now can we increase the Henrys? Yes, we need to increase some Henrys as well. So like here we need to write 0.8 or 0.9 or like that. Okay, so we just put here 1 Henry in order to get 5 volts. Okay, wait, we can increase it to like 2. Now they are near 5 volts. Okay, now our next step is to integrate this circuit with our PIC microcontroller. So we will take our PIC 18F 452 microcontroller. Okay, so we will put it here. Now we will connect our power source with the mClear or enable VPP pin. So it will enable the microcontroller. We also need to attach the output of this circuit with the RB0 pin or pin 0 of the port B pin. Okay, so this is, and after in the last we need to write virtual terminal. Okay, we can take virtual terminal from this side and put it here. RXT must be connected with the C6 pin and TXT must be connected with the C7 pin. So okay, this is our circuit. Now after this we need to move towards the so we need to move towards our programming. Now we will go to the microC. Okay, now go to file and new project. Here we need to write any name like Foxtrot power failure or anything and choose your microcontroller. Okay, now this is a wide main. So we just need to do one thing, and that is to first we need to write one while one. This is our infinite loop that will execute again and again after wide main. Okay, first we will declare our port B as the input pin. So we will write 0xFF. So now port B will be declared as the input port. All the pins can be used as the input. Okay, now what will be in while one, then we will write if port P dot F0 is equal to 1, then we need to write UART 1 underscore write underscore text power. Okay, now what is meant by this? This if condition will check that either the pin number 0, that is F0, pin number 0 of port B is having 1 on its is a logic 1 on it or not. So if it is logic 1, then the instruction within the parenthesis will be executed like UART 1 underscore write underscore text. And you also need to go to library manager in order to make these libraries functional. So UART. Okay, we also need to initialize the UART port. So UART 1 dot initialize, then dot initialized 9600. Okay, so this is underscore. Okay, so this is our initialization for the UART 1. So we will run it, but before going we also need to put one more if statement to check that if power is here or not. So we will write here power out. So when it is 1, it is power OK, and when it is not here, so it will be written as power UART1 write text power out. Okay, now we will save it. Okay, it is written UART1 underscore. So we need just to write init rather than the whole initialize. So we will run it. We will. Okay, now we will save it in a delta 000. Yeah. So yes. Okay, now also one more thing that you also need to put 4 megahertz crystal oscillator with this, or it is not going to work anymore. So we will write crystal, and this is our quartz crystal. Okay, so you need to like this, and okay, so this is oscillator, this is oscillator pin, and the pin number 14 is also with the oscillator. We also need to take 22 pf. Okay, so ceramic capacitors, they will work. You can connect any of the capacitors, they will work fine, like this and this. Okay, now it is 4 megahertz and it is also 4 megahertz. We can change it to 8 because we have used it in the programming as 8 megahertz. So 8 megahertz. So okay, now we will run it. Oh sorry, we didn't burn the hex file, so we will go and we will burn our hex file. So where it is delta 000. It is very necessary, so you have to take care about it. Okay, it's saying, oh right, it is saying power is okay. Okay, now when we will off it, now you can see that we are getting power out on the output port. Okay, so wait, one more thing, we can write delays function delay underscore millisecond and 1000, and here also delay underscore ms 1000. So we will change it a bit so it will work perfectly for us after the changing. So power out, and when we will, okay, now power okay and power out. So you can now simulate it in your Proteus. So thanks for visiting our channel.